Alright, it's time for another math easy solution. Turn to discuss further into integration of rational functions by partial fractions, and now look at example 6 of the example series. Basically, I'll solve this example, which states find integral of 4x squared minus 3x plus 2, all divided by 4x squared minus 4x plus 3 dx. Now this is pretty complicated. Now if we were to use partial fractions, first thing we need to realize is, well, this is not a proper fraction, because the numerator has an x squared, and the denominator has an x squared as well. Since the numerator and since the denominator is not a degree higher than the numerator, this is, well, not proper. So like I showed in my earlier videos, if this is the case, we first need to use polynomial long division. Polynomial long division. So we first divide this out to make it a simpler, a simpler fraction right here. So we will write this out: 4x squared, 4x plus 3. We write the denominator like this. You can see what I've done in my earlier video on polynomial long division, if you need a recap on that. So we put the numerator inside this division thing here, 3x plus 2. So now the first step we do is, well, we have a number that multiplies by 4x squared to get 4x squared here, so that's just 1. So we do that, then we multiply this whole thing, so we get 4x squared minus, well, 4x, and then plus 3. And now we just divide these out, and then we get, well, this is 0, this is negative 3x minus negative 4x, that's plus 4, so we will get, well, x. And then this 2 minus 3, that's just negative 1 right there. And now we have to do the same thing. There's nothing to carry down here. A number to multiply to get, well, to get x. Well, we can't multiply 4x squared by any number to get this unless it's a division. So this is basically the remainder. So we just stop right there. So that's a remainder. And now what this means is that our rational function is basically equal to 4x squared minus 4x. So this equals to now 1, and then plus the remainder x divided by 1. Now x minus 1 divided by 4x squared minus 4x plus 3. Yeah, and to save time, let's just put this inside the integral. So we integrate like this, dx. This equals to, well, now this part and then dx. So we know the integral of the first part, and then the second one is the tricky one. So I'll just get rid of the first part. We know that the integral of 1 dx, that just equals to, well, x plus, well, constant. I'll just say c1 right here. So now that we have that, now we have to look at this other part here, which is integral of x minus 1, 4x squared minus 4x plus 3 dx. So now we need to break down this 4x minus 4x cubed. I mean 4x plus 3, not cubed. So to break this down, well, let's look at this 4x squared minus 4x 3. To know that if we can break this down or not, because to use partial fractions, well, if we let this equal to 0 and try to find the roots, well, recall basically the quadratic formula. So if we recall this is just if you have ax squared plus bx plus c equals to 0, then the roots are x equals 2, x equals to negative b plus or minus square root of now b squared minus 4ac all divided by 2a. So these are the roots, and first thing we gotta know is, well, yeah, to be able to factor it, well, we need to know the roots. So first thing we need to do is first thing we need to do to see if we can factor out is check this right here. So this is our b squared minus 4ac. So this has to be greater than 0 because that's a square root. So this equals to, in our case, bring this down, that's just going to be equal to negative 4 squared, that's this, and then there's our c. minus 4 times a, which is 4, times it by 3 right here. Now this equals to negative 4 squared, that's just 16, that's positive 16 minus now 16 times it by 3, this is just, well, 48. So this equals to 16 minus 48. This equals 2. To solve this, this is negative 32. So now this is, well, less than 0. So what this means is that in the roots, so for example, if you have, let's say, x plus a times it by x plus b right here, if you were to reduce this quadratic, remember, these are just the zeros of it. So all these factors are the zeros. So in this case, we would have, well, a square root of a negative 32. Yeah, negative 32 in the square root. So this is, well, not real. Yeah, so this is not real. So we can't do that. These are imaginary numbers. So, yeah, thus we can't reduce this further, and now we also can't use partial fraction decomposition because we will get back to the same place we started. For example, let's look at this, what we have here, x minus 1. So we have this x minus 1 divided by 4x squared minus 4x plus 3. So this is not reducible, so if we were to write this as ax plus b, all divided by 4x minus 4x plus 3. As you can see right here, if we multiply both sides, the denominators just cancel out. We get x minus 1 equals to ax plus b. And then again, this coefficients have to equal. So again, a equals to 1. And this one here, b equals to negative 1. And we get basically the exact same thing. So we cannot do this. Yeah, so instead we try, well, completing the square. So we have this part right here, 4x minus 4x plus 3. So this part right here, we could complete the square because we know, well, if we have, in this case, 2x minus 1 squared, because this is, well, 4x squared. To get that, we needed to do 2x times 2x. And then this is negative 4x, and this adds up negative 2 plus negative 2. So it's the same thing here. If you expand this out, this is 4x squared minus, well, this is going to multiply by itself, 4x, and multiply 1 by itself. That's just going to be, well, plus 1. So that's what this part equals to. And again, to learn more about completing the square, make sure to watch my earlier video on completing the square in the video description below. So what this equals to now is, well, we could write this as, because this part here contains a 4x squared minus 4x, so we'll go 2x minus 1 squared, but there's an extra 1 here, so we have to subtract by 1, and then we add this 3 right here, so plus 3. So this equals to 2x, let's write this neater, 2x minus 1, then, yeah, squared plus 2, negative 1 plus 3 is plus 2. So we have this right here. So now let's get back to our integral right here. So we had an x over 1, so that's this part here. So we had an x minus 1 over, now this is going to be 2x minus 1 squared plus 2. So now we've written it like this, dx. So now what we could do is, well, this suggests that we could use the substitution. If we let u equals to 2x minus 1, then du equals 2, derivative of this, that's just 2, and then times it by dx. And then, so our dx right here is equal to du over 2. So again, we're just trying to simplify this whole thing. Now the x part equals 2, that's just going to be, well, move the 1 over side to here, so u plus 1, and then divide the 2 out, divide by 2. Let's write this better here, u plus 1 divided by 2. So now what we could do is, well, throw this inside. Throw all of this inside of this right here. This equals 2. Now it's going to be, now the x, that's going to be our u plus 1 over 2. Subtract by 1. Divided by our, now it's going to be, well, u squared plus 2. Then our dx, that equals du over 2. So I'll just put the 2 right here. So now what we can do here, just these are add the common denominator, multiply by 2 over 2. So we get here equals 2 u plus 1. So we can take this, and then we can take this 2 out, or just leave it right here. This is going to be du over 2. And then this is minus 2 all over u squared plus 2. Yeah, so now this is just algebra. Just get rid of all this. This becomes, these 2's multiply, so take it out of there, 1 over 4. And then we have right here u minus 1. 1 minus 2, that's just minus 1. Then u squared plus 2 du. So now that we have this part, what we could do is now break this into two derivatives. Integrals right here. So we get 1 over 4 integral, take this u out here, u squared plus 2 du, minus now 1 over 4 integral of 1 over u squared plus 2 du. So now that we have these two, let's just do these separately because it's easier that way. So the first one, 1 over 4 square root u over u squared plus 2 du. So this one, it looks easier to do substitution, because if we let, well, z equal to u squared plus 2 to the bottom, then dz, that's derivative, is going to be equals to 2u and then du. Or in other words, this u du equals to dz over 2. Now that we have this part, and again we can then just plug that in. Plug this in, so this equals to 1 over 4 integral now of, well, this is going to be the integral of, now this u du becomes dz over 2, so dz, and then we just put the 2 like this. And then the bottom is u squared plus 2, that's just divided by z. So this equals 2, multiply these out, 1 over 8, and then the integral of 1 over z, that's just, well, like I showed in my earlier video, that's just ln of z right here, absolute value of z. And then we add a constant, we'll just call this c2, because we already had c1 above. So now that we have this, plug in our u, which is u squared plus 2, and that's always positive, so we can remove this absolute value sign. So 1 over 8 ln u squared plus 2, and then plus c2. And now what are u squared plus 2 equals to? Well, we already know that. That's just our denominator. Yeah, because like I showed above here, our u squared plus 2, that's just 2x minus 1 squared plus 2. And that is, well, get back to here, that's just our denominator, 4x squared minus 4x plus 3. So this all equals to 1 over 8 ln 4x squared minus 4x plus 3, and then the constant c2. And this is always positive right here, so we don't need to do an absolute value. So now we have that, and now let's get to the second part of the integral. And that part right here is this one here, and that is just, well, let's just write that down, 1 over 4 integral, now it's a 1 instead of a u, 1 u squared plus 2 du. And now if we recall, so basically right here, yeah, recall my earlier video on the trig identity for integrals, this one right here, which was integral of 1 over let's call this x squared plus a squared dx. This equals to 1 over a inverse tan of x over a, and then plus constant right here. So if we recall this, then we could just basically rearrange this into the same form right here. So this would equal to 1 over u squared plus, well, now it's 2, that could be written as square root 2 squared, just so that we have an a squared there, du. So drag this down, this equals to, again, there's a 1 over 4. So this equals to 1 over 4, and then we just have this a right here. Yeah, so this equals 1 over 4, and now we have to put this 1 over a, which is this is basically right here, square root 2, 1 over square root 2 times it by inverse tan of x over square root of 2. Yeah, whoops, not x. In our case, it's u. Yeah, and now we just will add a constant c. Let's call this now c3 because we already had c1, c2 taken. So now this equals to plug in the u, which is, if we scroll back up, what u was, u is just 2x minus 1 right there. I'll just divide this out. Okay, so now getting back to here, we get that basically 1 over 4 square root 2 times by inverse tan of 2x minus 1 divided by square root 2 plus c3. So now we have this, and now we can just add all of these together. So we get now the integral of 4x minus 3x plus 2 over 4x squared minus 4x plus 3 dx. This equals 2. And then scrolling up, we had, well, this is the third one. This is the third term. And then this is the second term right here. And then the first term, and again, notice that we had a minus here, so we'll include that. And then the first term was the very, very beginning, which was right over here. We had this 1, so we had this x right here. So that's the first term. So we go back to here. Yeah, this is really tedious, but it's a good example to get used to all this. So this equals 2x, and then plus, and then what's the second term right here? 1 over 8. 1 over 8 ln of 4x squared minus 3x, minus 4x plus 3. And then right now I'm ignoring these c1, c2, c3. I'll just combine them into one constant c. And then we have to subtract. It's not a plus, this is a subtract, because there was a subtraction sign right there. This is now 1 over 4 square root 2, and then times it by tan inverse of 2x minus 1 square root 2 plus a constant c. And this is finally our answer ready. I'll just highlight this all. So that's finally our answer. Now, an important note in this pretty extensive example is basically this example illustrates now the general procedure for integrating a partial fraction of the form that is ax plus b divided by ax squared plus bx plus c, where basically this is called a discriminant or whatever, but I don't know the lingo for that, but anyways, where b squared minus 4ac minus is less than 0. So this is where the roots right here are not real numbers, like I showed above. And again, this is called the discriminant, or discriminant. That's what it's called. Yeah, and in this procedure for these, basically we complete the square in the denominator and then make a substitution that brings the integral into the form of, well, cu, because we added a substitution, c, and then times u plus d divided by u squared plus a squared du equals to, again, c, take that out, u squared plus a squared. So this is a general way of writing it, and then plus, well, this d, coefficient d, 1 over u squared plus a squared du. So this is exactly what we did. And then in this procedure, basically the first integral is a logarithm, that's this one, and then the second one is expressed in inverse tan, like we did as well. Anyways, that's all for this pretty extensive example. Hopefully you followed through this long video. And like always, you could download these exact notes in the link below. And thanks for watching, and stay tuned for another Math Easy solution.